So, like I said, 1 Faraday of electricity is equals to 96500 coulomb. So that means if one electron is involved in producing a number of volume or 1 mole of a substance, then it means it is 1 Faraday. So if, for instance, in this equation, copper 2, in the formation of 1 mole of copper from the copper 2 ion, 2 moles of electrons are required. So this implies that you have 2 moles of electron required. So in terms of Faraday, it is 2 Faradays. And 1 Faraday is 96500, meaning 2 multiplied by 96500 coulomb is required. So let's take note of that. Then, like I said, going to the solution now of the question. The question is asking us to determine, sorry, I did the question. Sorry, searching for the question. Yeah, this one's free. Okay, the question says during the electrolysis of dilute HSO4, we have 0.05 more of electrons. And the question is, what volume of gas was produced at the anode? So what volume of gas is produced at the anode? So we have seen in the previous video that oxygen is the gas produced at the anode from this overall reaction. So what we are going to do is this. From this stoichiometric equation, it is clear to us that to produce 1 mole of oxygen gas, we need 4 moles of electron. That is to produce 1 mole of oxygen gas. But the question is actually asking, what is the volume of oxygen which 0.05 mole of electron we produced? And then we know one standard that what 1 mole of a gas has a volume of 2.4 dm cube. So 1 mole of a gas has a volume of 2.4 dm cubes. So then, for us to know how many dm cube is of oxygen is produced, then we need to know how many moles of oxygen is generated by 0.05 mole of electron. So the equation has already given us an important information that 1 mole from here, you can infer that 4 moles of electrons gives what? 1 mole of what? Oxygen, which is the gas in the question. Then what we want to know is this: if 4 moles of electron will give 1 mole of oxygen, then what was actually supplied is 0.05 mole. Stoichiometrically, for us to get 1 mole of oxygen from the discharge of hydroxide, then we need 4 moles of electrons involved. So, but the number of mole of electrons supplied is 0.05 moles. So we now need to know if 4 moles of electron will give us, or is required for 1 mole of oxygen, then how many moles of oxygen will 0.5 mole of the electron will give? So 0.5 mole of same electron should give a mole, which we don't know. We call it S of oxygen. How this is understood? The equation, the balanced geometric equation, shows that 4 moles of electrons are involved in the generation of 1 mole of oxygen. But the question gives us 0.05 mole of electrons. So what will if 4 moles of electron will give 1 mole, then what will 0.05 moles of electron give of oxygen? So we first need to determine the number of mole of oxygen that is generated. And once we know that mole, then having known that 1 mole of oxygen has a volume of 22.4 dm cube, then the solution is done. So this is a standard. dm cube is a unit of volume, a centimeter cube, just like you have cm cube, centimeter cube, liters, and others. So we need to find this S, and as you know, how do we do this? We do that by cross multiplication. We multiply this by this, then equals to this multiplied by this. If you go by that, you're going to have 4 multiplied by S, 4S, 0.05 multiplied by 1. Then we divide both sides by 4 to eliminate this 4 and make S stand on its own. Then you are going to have this. So, of which, if you press your calculator, your 0.05 times 1 is 0.05, then by 4 gives 0.0125, 0.0125 mole. So of oxygen, not of electrons. It means the 0.05 moles of electron will give 0.0125 moles of oxygen. If 4 moles, according to this equation, will give 1 mole, oxygen is O2. Not of mole is whatever it says. This is 1. If there's no number here, it means it is 1. So don't look at this as 2 moles of oxygen. No, this is 1 mole of oxygen, 2 moles of water, 4 moles of electron, 4 moles of hydroxide ion. So this electrolysis will generate 0.0125 moles of oxygen. But the question does not ask us to calculate the number of moles of oxygen which 0.05 mole of electron will generate. If the question has said so, then this would have been our answer. But the question says the volume. But to get the volume, we need the mole. So then going to the volume. To now determine the volume, that is of oxygen, then we bring the standards. As far as temperature and pressure, we know that 1 mole of any gas, in this case our gas is oxygen, so 1 mole of oxygen has a volume of 22.4 dm cube. Then if if one mole has this volume, then how many has this DM cube? How many DM cube will 0.0125 mole have, which is what is generated in the electrolysis? So we now say 0.0125 moles of oxygen there will have, let's call it YDM cube, a volume equals to YDM cube. So Y is our unknown, which we are going to be finding now. Then the same way by cross multiplication, you can say 1 multiplied by Y, you have Y. Then 0.0125 multiplied by 22.4, that's 0.0125 multiplied by 22.4. So this gives us, if we do it, it should give us what it will give us. So, oh my God. 0.0125 multiplied by 22.4. It gives us 0.28 dm cube. So that is the answer, the volume of oxygen that will be generated. That's the volume of the gas. The gas, like I said, is oxygen, as we have seen in the from the electrolysis of H2SO4. So, and from here, the correct option is C, 0.280 dm cube. This is understood. So it is very simple. You know, just what we use is the electrons, because the information in the question gives us electron. The question has specified, as instead of electron, has given the current or the quantity of electricity. They would have used that. If the question had said 0.05 Faraday, they would have said, okay, from this equation, 4 Faradays are required to give 1 mole. Then how many moles of it will the given Faraday, 0.05 Faraday give? So it all depends on what the question decides to give. So it can give you electron, it can give you electricity, current, and what have you. So then you know what and what to relate. So getting the correct equation, the analytic or cartesian equation, is very important. If you can't get this correctly balanced, then we may not know the right number of electrons involved. If it were to be the case of copper 2 ion, copper 2 positive plus 2 electron giving 1 mole of copper, then that is we need, instead of, you need 2 moles of electron to give 1 mole of copper. And a mole of a substance is equals to a molar mass of that substance. So sometimes instead of using mole, you might have to use the mass in case you have to find the mass. So which is to say that like 1 mole of oxygen has a mass equals to 16 times 2, that is 32 gram. Then 1 mole of copper has a mass equals to 63.5 or 64 gram. So those are the relative atomic masses or the molecular masses of those respective elements. So as we move along, maybe we'll come across other questions on electrolysis. Then we'll see how they are solved. So where we are going to apply the Faraday laws to solve questions where questions may involve mass, calculating the mass, or even calculating the quantity of electricity, current, and what have you. So as we go further, then we'll come across such questions and then throw more light on how they are handled. So that is that about that question. If there's any gray area, then maybe drop the question in the platform. So we move to the second question, and that's maybe the last question. So the second question goes, so what volume of 0.5 mole dm cube of sodium carbonate solution 0.750 mole per dm cube sodium carbonate solution. What volume of this solution could be diluted to 250 centimeter cube? Diluted to 250 centimeter cube. Diluted to 250 centimeter cube to reduce the concentration to 0.025 mole per dm cube. 0.025 mole per dm cube. So this question is about dilution. So sometimes we dilute solutions. We have a concentrated solution, and we are interested in a lower concentration. So we do what we call dilution. And dilution is done by adding measure the quantity of water into the original solution so as to bring down its concentration. It's just like you're trying to reduce the concentration of the sugar in your water. Maybe you find the sugar content is too much, then you decide to add more water to reduce it. That is like dilution. So when you dilute a solution, then there will be gain in volume. The resulting solution will have more volume, a larger volume than the original, because you must have added some solvent, like in this case water, and the concentration will drop, then the volume increases. So this question is simple because there's a simple formula to answer it, which is by the dilution principle. So what we have here is this. The dilution principle gives us a formula C1 V1 equals C2 V2 to solve any question, where C1 is the original concentration, V1 is the original volume, C2 is the final concentration, that is the concentration to which you diluted. You dilute from this concentration, this high concentration, to a lower one by adding some water, then meaning the volume will grow from V1 to V2. And the question is asking us about the initial volume. Yeah, about the initial volume. Okay, the question says, what volume of this concentration? You understand? So the volume that has this concentration is the initial volume. So what does that mean? Initial volume is the unknown that we have to find. Then the initial concentration is 0.7050. Then they are diluted to a new volume of 250, and then a new concentration of 0.025. So we can see from here we have all the information needed to determine the value of B from this formula. So what we just do is to substitute and find it. Take note, mole dm cube, mole per dm cube is the unit of concentration. The concentration is actually a measure of the amount in mole of the solute in 1 dm cube of the solution. So cm cube is a volume unit. So from the dilution, from this formula, we can make V1 the subject by dividing both sides by C1. So we have V1 equals C2 V2 over C1. So on substituting the values, C2 is 0.025, V2 is 250, and the C1 is 0.750. So this will give 0.025 times 250, 0.75. So this gives 8.0, and so on. Then to one decimal place, it will be 8.3 centimeter cube, which is the answer. So from your options, the option D is the answer. So this question of dilution is a very simple one. So all you need to do is use this formula and take note that you are diluting from a higher concentration C1 to C2, and the initial volume of the solution is V1 and the final volume is V2. In case you are confused as to which, maybe you are given two volume as to which one is the final volume V2, the larger volume is the V2, because when you dilute, you are adding, just like you have a cup of tea with added sugar. So you have added too much sugar mistakenly, and it makes it too sweet. You feel the sweetness is too much. It is too concentrated in sugar. So you want to dilute it by adding water. Then you are going to get something definitely a volume larger than the initial volume. So the initial volume is always larger, but for concentration, C1 is always larger than C2 because the initial concentration was small. That is the essence of dilution in the first place. So taking note of this formula, you can calculate. You might be given every information about these two, and then one of these is to be found. Then you should be able to do that. So these two questions are what we're going to, do for this very class. Then as we move, as we move on, we'll be coming across questions that has to do with electrolysis, and then that will now lead us to talking more about them. As per electrolysis, I think we've said almost everything there. We still have others like applications to talk about. When we come across question relating to that, we will definitely come across such, even if it's not in this very 2019 question. So we will still come across question that will now introduce us to the other form of questions or calculations that are involved. But the summary of what is required to answer any calculation has been given as with the Faraday laws, the first and second laws of electrolysis. So go through this, find a similar question from other years and stuff. If you encounter difficulty in doing that, then you can let me know, throw more light on it. Take at this juncture, we uh, we can say we are done for today. Then maybe in the next chemistry class, we can continue from question theory onwards. So thank you.